All right, so I'm just going to give you a couple hints to get started here on number 7, since I'm getting lots of questions about it, which makes sense because it's a tricky problem. So part A says, what is the period of each arch? So how long does it take to complete one cycle? And so as we look at the picture, then I've got a rough approximation for a cycle, of course, is, every time it gets back to the x-axis. Well, when does it get back to the x-axis? Well, when y equals 0. And so basically we need to set this equal to 0. R is some constant, and so R is not 0. So basically we need to set 1 minus cosine of t equal to 0, and figure out how often that happens. So it's back to a good old unit circle question. So I'll let you think about that a little bit. Then it says find the arc length. First we need to know how long the cycle is, and so that's going to go in the upper bound of the integral. And then the arc length formula is the integral of the length of the velocity vector, basically. And so to do that, we're going to take x prime, and that's going to be r, and then 1 minus cosine t, and then we have to square that whole thing. And then we'll do the same thing with y. We'll take the derivative of y, which will give me r times, I think, just sine of t, and square. And the tricky part about this one is that the variable of integration is t. R, again, is just sort of a constant. Notice we've got r squared in both those things, and it's underneath the square root. So really we can factor an r out in front of that integral. And now I won't finish this, but you'll evaluate that integral on your calculator. You'll get a number. That number gets multiplied by r, and that's the arc length, the length of one cycle in terms of r. The slope question seems to be going better for people, but basically you do dy dt, or y prime, over x prime. The r's will cancel, and you'll get a formula that just has t in it. Hope that helps. If you continue to have questions, of course, be sure to let me know.